NASA's journey to push the boundaries of space exploration has been marked by groundbreaking achievements and invaluable contributions to science and technology. However, this path has also been shaped by ambitious projects that faced substantial setbacks, or even failure. These projects, though unsuccessful in their original missions, provided critical lessons that guided NASA in refining its strategies, safety protocols, and engineering practices. From tragic accidents to technical missteps, each of these 5 failed NASA projects underscores the complexities and risks of pioneering in space and reminds us that even failure can be a stepping stone toward future success. Number 5. Apollo 1, 1967. Apollo 1 was intended to be NASA's first crewed mission under the Apollo program, laying the groundwork for America's journey to the moon. The mission's objective was to conduct an initial manned flight test of the Apollo command module in low Earth orbit. Tragically, on January 27, 1967, during a routine launch rehearsal, a fire erupted inside the command module on the launch pad, killing astronauts Gus Grissom, Ed White, and Roger B. Chaffee. The cabin's pure oxygen environment, along with highly flammable materials, turned the module into a death trap within seconds, leaving no time for the astronauts to escape. The Apollo 1 disaster deeply impacted NASA and the United States, triggering widespread changes in spaceflight safety protocols and hardware design. The command module underwent extensive redesigns, with fire-resistant materials replacing flammable ones, and oxygen levels in the cabin were reduced during ground tests. While Apollo 1 was a devastating failure, the lessons learned ultimately led to the success of future Apollo missions, helping NASA accomplish the ambitious goal of landing astronauts on the moon. Number 4. Space Shuttle Challenger, 1986. The Space Shuttle Challenger disaster on January 28, 1986, was one of NASA's most tragic events, resulting in the loss of all 7 astronauts on board just 73 seconds after liftoff. The crew included Krista McAuliffe, who was set to be the first teacher in space, capturing the attention and hearts of millions of Americans, especially school children watching the live broadcast. The disaster occurred when an O-ring seal in one of the solid rocket boosters failed due to unusually cold temperatures on launch day. The failure allowed hot gases to escape, leading to the structural breakup of the fuel tank and causing the shuttle to break apart in mid-air. The Challenger disaster had a profound impact on NASA, leading to a complete suspension of the shuttle program while a thorough investigation was conducted. The Rogers Commission, appointed to investigate the tragedy, revealed that NASA had been aware of the potential for O-ring failure in cold weather, but had proceeded with the launch despite engineers' warnings. The findings brought significant changes to NASA's approach to risk management, engineering oversight, and communication. The disaster not only reshaped NASA's safety protocols, but also emphasized the need for a safety-first culture in space exploration, impacting the future of manned missions and leading to the eventual redesign of the Space Shuttle program. Number 3. Mars Climate Orbiter, 1998. The Mars Climate Orbiter was designed to study the Martian atmosphere and climate, providing critical data for future Mars exploration. However, a metric imperial conversion error in the orbiter's software led it off course, causing it to burn up in the Martian atmosphere during its orbital insertion attempt. The mistake was a simple oversight. One engineering team used metric units while the other used imperial, resulting in a $327 million loss and an abrupt end to the mission. This high-profile failure emphasized the importance of unit standardization and precision in interagency communications and led to a NASA-wide initiative to improve quality assurance protocols. The Mars Climate Orbiter incident underscored how even small errors can lead to catastrophic outcomes in space missions. While the spacecraft itself was lost, the experience improved NASA's approach to project oversight and cross-team communication, helping ensure the success of future Mars missions. Number 2. Space Shuttle Columbia, 2003. Columbia's STS-107 mission was a scientific research endeavor focusing on areas such as life sciences and combustion. During launch, however, a piece of foam insulation broke off from the external fuel tank and struck the orbiter's left wing. This damage allowed superheated gases to penetrate the wing upon re-entry, leading to Columbia's tragic breakup over Texas on February 1, 2003, and resulting in the loss of all 7 crew members. The disaster shocked the world and raised critical concerns about the safety and reliability of the shuttle program. In response, NASA conducted an extensive investigation, resulting in 29 recommendations to improve shuttle safety and maintenance procedures. These findings highlighted structural vulnerabilities and the risks of foam insulation shedding during launch. The Columbia disaster not only grounded the shuttle fleet for over 2 years, but also prompted NASA to reconsider its approach to manned spaceflight, eventually leading to the program's retirement and influencing the design of safer, modern spacecraft. Number 1. Constellation Program, 2005 to 2010. Launched in 2005, the Constellation Program was NASA's ambitious plan to develop new spacecraft and rockets capable of returning humans to the Moon and eventually reaching Mars. The program aimed to create a new crew vehicle, the Orion capsule, and 2 new launch systems. However, technical challenges, budgetary issues, and shifting priorities led to significant delays and cost overruns, making it unsustainable. In 2010, the program was officially canceled, leaving many within NASA disappointed, but spurring a re-evaluation of long-term space exploration strategies. Though the program was ultimately scrapped, it left behind technological advancements that influenced subsequent projects. The Orion spacecraft, initially developed under Constellation, was repurposed for the Artemis program, which aims to bring astronauts back to the Moon. While Constellation didn't meet its goals, the lessons learned from its challenges informed NASA's current approach to exploration, emphasizing sustainable missions, international collaboration, and flexible strategies for crewed deep space exploration. Thank you for watching. If you enjoyed it, please like and subscribe. Until next time.